Back to water, aqueous systems, and solutions.
Of course, before we start, we must know the fundamentals of everything. Aqueous solutions, all these things. Just what are they?
Let's start with Will taking out Siri. Please ask Siri, what is an aqueous solution?
Hey, didn't get that. I got this. Google, what is solution?
Solution, a means of solving a problem or dealing with a difficult situation.
I think that's it.
I think that's wrong, Will. No mastery for you.
Oh god, no gold star.
A solution is a mixture of a solute and a solvent. Usually water is the solvent, and solutes can be anything from salts to acids. Now, so you see, aqueous solution is any water that contains dissolved substances. For example, please add salt to water, Will.
Yeah, I got this. I like that, don't you?
As you can see, the salt is dissolved in water. Thus it is known as a solute. The dissolved particles, meanwhile, the water is solvent, the dissolving medium.
Solvent? Solute.
Of course, in this world there are more than just solutions. As we know, solutions are homogeneous mixtures. What about the non-homogeneous or heterogeneous mixtures?
Ooh, heterogeneous mixtures.
Well, please put some sand and water in that glass.
Okay, if you say so. Yeah, that sounds...
Suspension, which is milk. Now, draw orange juice.
Orange juice is so nice.
That is a colloid, where the particles are smaller than suspensions but larger than solutions.
Yeah.
Thus, you can see solutions, colloids, and suspensions all share different properties. As you can see, the best way to test solutions, colloids, and suspensions is using the Tyndall effect. The Tyndall effect is that particles scatter light. Thus, the larger particles in a mixture, the more light will be scattered. This is the reason why you can't see the physical light passing through water. Water's particles is too small to scatter and reflects light large enough for us to see, but we do so in other mixtures.
Dude, light is so cool.
Now, what about solubility?
Ain't nobody got time for that.
Let me explain. The whole solubility is based on rules that like dissolves like. Do you know what that means, Will? No. That means that no, don't use Siri. That means that polar things dissolve in polar materials, while non-polar things dissolve in non-polar materials. For example, salt is an ionic polar compound. Thus, it dissolves in the polar compound water. This is also the reason why oil or hydrocarbons don't dissolve in water, as hydrocarbons are non-polar.
I think I achieved full mastery.
Also, for solubility, we must understand the solubility curve. As you can see, the higher the temperature, the higher the solubility, usually.
When making solutions, it is very important to understand what factors contribute to solubility and the rate of formation of solutions. Are you aware of these factors, William?
Let me guess. Temperature.
One main factor is temperature. For solids, during an endothermic reaction when temperature is greater.
Okay, what else?
One final question regarding solubility. Do you feel the pressure?
What pressure? My body is ready.
What is the effect of pressure on solubility?
Okay.
Well, there is no real effect on pressure for solids and liquids, but for gases and liquids, the partial pressure is proportional to the solubility.
Now we've touched on solubility. Pop quiz. Surprise. What are electrolytes?
The things in Gatorade?
Dummy. Electrolytes are any compound that conducts electric current when in aqueous solution or in a molten state, such as that salt in the water. That is an electrolyte.
Okay.
Now that you have shown mastery in the scientific method and various other sections of chemistry, here's your final test. You must demonstrate complete mastery of solutions in order to become Chem King.
Okay.
The first part of this showdown is to make a 100 milliliter salt water solution with 0.12 molarity. How do you go about doing this, Will Zhang?
What?
Do you need some help?
Okay, yeah, sure, please.
The formula is molarity
Oh, molarity.
equals moles of solute over liters of solution. Now, do you know the molarity you need? It's 0.12.
Oh, okay.
in case you weren't paying attention.
Okay. Thank you. Thank you. Thank you.
Now, do you know the liters of solution you need?
I did not
It's
get that.
0.100 in case you weren't paying attention.
0.0. Wait, what? 0.010.
No, 0.100. You fool.
0.100. Okay.
Now, what is the unknown?
Oh, it's x. So it would just be 0.100 times 0.12, which equals to 0.012 moles. I'm so good at this.
You're on your way to becoming the Chem King.
Oh, thank you.
Alas, adding on, we must understand V over V and mass over volume. Volume over volume is volume percent concentration, such as how concentrated a solute is in the total solution. Mass over volume is mass over volume concentration, which describes percentage of mass of solute in solution. Bow down to me. Now to dilute a solution, you take a portion of the original solution and add water as the moles of solvent to liters of solution ratio is reduced.
Okay.
Are you aware of hydrogen bonding?
Hydrogen bondage?
No! Water's hydrogen bonding is actually what makes water so safe and useful for humans to drink and use for other purposes. The intramolecular attraction found in water allows it to stay liquid for a much larger range of temperatures. It also creates two unique phenomena, cohesion and adhesion. Do you know what they are? Please don't look it up, Will.
Come on, dude, I'm being self-directed.
Adhesion is why water sticks to the bottoms of solids like glass. It is what makes water adhere to many substances. Cohesion, on the other hand, is when water molecules are attracted to each other. They adhere to each other. Do you know what this causes, Will? Phenomena like surface tension and capillary action.
Oh my god.
So this is why hydrophilic substances far outnumber the hydrophobic ones, because hydrogen bonding causes water to be a great solvent. It allows water to dissolve a large majority of substances that can be dissolved.
Too much information.
Can you tell me the difference between saturated, unsaturated, and supersaturated solution?
One is fat, one is not fat, one is super fat.
But in all seriousness,
An unsaturated solution is when there are more solute can still be placed in the solvent, while in a saturated solution, more of the solute can still be dissolved by the solvent. Supersaturated solutions are when there is more solute than can be dissolved by the solvent.
Like when there's too much sugar in lemonade, so there are particles floating around.
not as good as Will's lemonade.
Okay, whatever. I'm done. I'm so done with this.